Hi, everyone. I'm here today with IndustrialML's principal software architect, Jason Truesdell. And we want to talk to you a little bit today about some of the challenges of data integration in legacy factories and some of the ways in which we overcame those challenges. Jason, thanks for joining me today.
Good to be here.
Yeah. So let's just dive right into it. First question I wanted to ask you is, what are some of the biggest challenges that we face with gathering factory floor data? And I guess what companies like us generally face with gathering factory floor data, especially in older factories?
Yeah, so basically the main challenges are there are a bunch of disparate devices. They don't all have the same way, the same protocols for communication. And we don't necessarily have the benefit of some of the newer Industry 4.0 tools that are available for new installations, new factories. We can't expect those sorts of things to be already deployed. So basically, we need to integrate with a lot of legacy programmable logic controllers, sensors that sometimes aren't even internet connected. They're often based on old serial port technologies. So we basically have to be prepared to deal with proprietary and sometimes standardized but older technologies. There isn't a single uniform protocol that we can just use for every customer, right? We don't. We also can't expect that any of the deployed technologies use current tech industry expectations for open protocols, security standards, and that sort of thing. So sometimes we actually have to take on the effort of helping the customer think through things like network topology that will keep their site secure, but also allow us to collect the data that we need. So it's not just a data extraction. Sometimes it's literally consulting with the customer on how they should architect their internal network to give them secure access to their own data.
So one of the things that you mentioned was about more open protocols and the security concerns that they come with. But setting that aside, why can't we just opt for a solution where we have the same protocols that we recommend for every customer? Why couldn't we just say recommend the same sensors for every customer?
Well, I mean, it's very, very expensive to retool for most factories, and sometimes it takes. I mean, it can take 7-8 months just to get them to install a single sensor. The
Right.
factories don't necessarily move at the same speed that that software can. And it's just not entirely realistic to say, okay, I need you to go and replace all of your equipment with MQTT capable devices or that sort of thing. And a lot of the companies that use these newer devices, I mean, we're happy to integrate with them, but a lot of the companies that are working with the newer MQTT type devices are assuming a more or less self-service onboarding, and that's really, really burdensome for a lot of companies. They don't necessarily have an internal technology organization to go and figure out how to integrate those things. They have controls engineers and operations managers, but it's not the same skill set that they would expect to repurpose for it.
So there are a lot of tools out there, and I'm not going to name drop them because the point of this is not to bag on any potential competitors or anything. But there are plenty of tools that claim that they can integrate with any data source, and plenty of them have pretty extensive libraries of communication protocols that they can interface with. But in our experience, we found that it's not really tenable to just piggyback off of one of those systems, and we had to build out a lot of our own infrastructure. What was some of the decision making that went behind building out some of that stuff for ourselves?
We basically needed to have some control over deployment on site. And a lot of the available solutions are either, sort of not extensible gateways that we might not be able to go and add our own, they might support every protocol but the one our customer uses. And so that was the main thing.
Other solutions that claim they can integrate data from a variety of sensors, you said so far, it's very often the case that it could be any sensor except for the one that our customer has, and especially with older factories, that tends to be true.
Okay, so yeah, so basically, our main concern was, would our initial customers' needs be met, and would it be something that we could grow with? And in our case, it seemed to make the most sense, since there wasn't a lot of commercial off-the-shelf software for the hardware that our first pilot customer was using. We basically had to build something. And so my objective when building it was to keep it as flexible as possible, not make too many assumptions about the type of devices that we'd be connecting to. And so we made it possible to build plugins and basically wire in new types of devices as soon as we understand enough about how they work.
So what you were hinting at just now was, we have this challenge. We can't necessarily piggyback on other systems, which might not be totally comprehensive in terms of data sources. But by that same token, it's not necessarily the best solution for us to create a system like that ourselves, because inherently we're only going to have a limited number of data sources that we're able to interact with at any given time.
Fair enough.
So what that implies about how we needed to build our architecture is, as you mentioned, make it as flexible as possible for the next data source, and make it faster to integrate the next data source where it may have taken months and months for the first one. So can you talk in a little bit more depth about some of the work that we did in order to make that possible?
Basically, we tried to find a reasonable level of abstraction that wasn't so so abstract as to be, kind of too complicated to work with. So we basically treat data collection as a list of devices that we need to communicate with, a list of jobs to retrieve data from them, and a set of schedules. We define schedules, the jobs and the connections to these devices, all in a simple configuration file format. And it's really simple for us to just go and say, okay, there's this new type. Once the type of device, once we built support for it, it integrates into the same simple config format, and a solutions engineer or somebody who is primarily focused with onboarding a customer can just write up that config file, confirm with the engineers at the customer site that it contains the data they want, and then it can just be deployed, can be updated whenever we determine that there's something new that we need to collect from. And so we're not writing custom code for every possible deployment. We're writing just enough code that we can manage our gateway device that sits on the factory floor for each customer. So anyway, the system design is flexible enough that we can basically define the communication protocol in code, a set of rules for translating the configuration file into the steps that are necessary to interact with it, and basically, as soon as we understand protocol, it's it takes nothing to deploy. It all works the same way, no matter what devices we're talking to.
So given what you've just talked about, what are some of the ideal requirements that a manufacturing customer of ours would have in order for us to appropriately integrate their data? And if, say, they are unable to meet those requirements, they don't have the internal skill set to meet them, what are some ways we can help them navigate through that lack of expertise?
We generally expect most manufacturers to have, most of the small to medium-sized manufacturers have at least one or two controls engineering background members on the team. And so they're generally aware of the landscape of PLCs and other devices that are used to manage the work on their line. And so generally speaking, we mainly need the ability of the controls engineers to help us identify what data points are important and where on the network their devices are, if they're into Ethernet connected. or in, in a particularly old school place, we haven't actually had this scenario yet, but, in theory, our device could just as easily talk to older serial port based PLCs. I think, Ethernet enabled equipment with relatively simple and not very secure protocols have been around for 15 years or more.
Just about, yeah.
So we're not necessarily talking, we're not going back to the dark ages with most customers, but we're also not expecting them to be, fully IoT enabled, right? They're not going to have all of those modern sensors deployed, or if they do, it'll be one or two. And so, we basically need them to know their business and know what data they have, and be able to discover, if they're not necessarily the ones that did the original programming of their PLCs, they need to be able to discover where their data is stored. So that can be that can require some back and forth. It can take some time, but we don't actually really have very many specific expectations of the hardware topology of our customer. The main consideration is, we actually want to work with them, right? We're not just throwing a set of solutions over the wall and letting them kind of fend for themselves. So the main thing is they need to be willing to work with us in terms of making the network reachable to us, making their devices known to us. There's no magic auto discovery protocol for factory data yet. So
we've done a lot of this infrastructure work while working with our early customers across Japan and Vietnam. Now, given all of this, how will we work with our next customer? What approach will we take with our next customer in order to integrate all of their data? And how might this apply across multiple manufacturing sectors?
Well, I mean, the start of the process is really, we sit down with their plant engineers, their operations people, their in some cases their controls engineers. We basically want to get really familiar with their product and their manufacturing process, and then we need to understand obviously what sensors, what data they have, what they currently have, and what they're interested in collecting. Because every plant has, just like software, there's there are things that are ready, and then there are things that they would like to be able to accomplish. And so the first part of our process is really just sitting down with people and trying to understand what their needs are. And then we also want to understand what types of problems they're trying to solve in their plant. Are they worried mainly about efficiency, power management? Are they worried mostly about equipment failure or maintenance prediction, or are they worried about product quality? We try to figure out what their first priority is and what data is available, and we try to meet somewhere in the middle with a solution that starts collecting the data they need and shows them the data that they want. We mainly want to think about what would give them value today and still be flexible going forward. And that, it's going to depend a lot on what their strategic goals are. So, it's a solutions engineering process. It's not just a set of technology. We actually have to work with our customers to help them become successful.
Thanks so much, Jason. That was a really enlightening conversation. Look forward to doing another one of these with you again in the very near future. There are a lot of really unique elements to the industrial ML technology stack that go, way beyond just the external functionality that people see. I look forward to accentuating more of those over the coming months.